Hi everyone, welcome back to Sri Sampath Vinayaka Learn Easy channel. I hope all you are doing good. Now we will discuss the try this, do this, think and discuss questions after the exercise 1 mark. Now see a question in page number 33, that is do this. He gave that set A as 1, 2, 3, 4, set B as 2, 3, set C as 1, 2, 3, 4, 7 and empty set empty. Fill in the blanks with subset or does not subset, we have to write mark. Here see, the first one is A blank B. One check, is all the elements of A are there in B? No, ma. So here we have to write does not subset. Here see, is all the elements of C are there in A? No. So that's why here we will write does not subset. Why? Because see, in this C we have 7, that 7 is not there in A. Coming to the third question, B blank A. Is all the elements of B are there in A? Yes, there are. So we have to write subset. A blank C. Is all the elements of A are there in C? Yes. So we have to write subset. Is all the elements of B are there in C? Yes. So we have to write subset. See my empty set is subset for all the sets we know. So that's why here I have to write subset. Coming to that second question. State which of the following statements are true. Okay, here see empty set equal to empty. Yes, it's true. Okay. Coming to the second question here, empty set equal to 0 is said. This is a set. This is a element. That's why it is false. Okay, Nama? Now, again see, this is an element and it is a set. That is why here also it is false. Okay, try this from the same page number 33. He gave us set A, set B, okay, and he is asking you to check whether that A is subset to B or B is subset to A. Firstly, I have to write the set A into roster form. Set of quadrilateral means, see, here I will write parallelogram. Rectangle, square, rhombus, kite, trapezium. These are the different types of quadrilaterals comes under set A. Set B is given as square, rectangle, trapezium, rhombus. Once see, all the quadrilaterals of set A are not there in B. That's why A does not subset to B. Okay, but all the elements of B are there in A. So B is subset to A. That is your justification. You have to write that. Okay, now coming to that second question here. He gave set A as A, B, C, D. How many subsets does the set A have? So we know number of subsets is equal to 2 power its cardinality. Okay na? As we know the cardinality of the set A is 4. That is we have to write 2 power of 4. 2 power of 4 is equal to 16. So the option C is our correct answer. Okay. Now P is the set of factors of 5. We know the factors of 5 are 1, 5. Factors of 25. We know that 1, 5, okay, 25. How you know, no? If you don't know how to write factors, just you have to write 25 as 1 into 25, 5 into 5. These are the factors. Similarly, factors of 125. Factors of 125 is R. 1, 5, 25, 125. Okay. Now he is asking you which one of the following is false. See is all the elements of P are there in Q or not? Yes. So it is true. Okay. All the elements of Q are there in R or not? Yes. So B is also true. Is all the elements of R are there in P? No. That's why it's false. That is our answer actually. Here see, all the elements of P are already there in R. So it is also true. The false one is R is subset to P. Actually R is not subset to P. Now see ma, A is the set of prime numbers less than 10. Okay, prime numbers less than 10 means 2, 3, 5, 7. Here see ma, B is the set of odd numbers less than 10 ma. Okay, then 1, 3, 5, 7, 9 comes into that set. C is the set of even numbers less than 10 ma. Okay, 2, 4, 6, 8. Those are the elements comes into the set. How many of the following statements are true? He is asking. Here see ma, is all the elements of A are there in B? Okay, no. So it is false. Is all the elements of B are there in A? No. It is also false. Is all the elements of A are there in C? No. It is also false. Is all the elements of C are there in A? That is also false ma. Okay. Is all the elements of B are there in C? No. So it is also false. Last one C. Is all the elements of C are there in B? C ones? No. So that is also false. That means all the given questions are false. We will discuss the think and discuss question from the page number 34. In that, the first question is empty set subset to every set? He is asking us to justify its answer. Yes, empty set is subset to every set. We know that. We have to justify its answer ma. How means we know no element of the empty set can be missed in any set. Okay, no element of the empty set can be missed in any set. Because empty set means there is no element. As it is not having any element in it, how can an element of that empty set miss in any other set? So that's why empty set is subset to all the sets. See ma, is any set subset to itself? That is the question. Yes, we know. Every set is subset to the set itself. Because see ma, every element of the set definitely belongs to the same set. That is why every set is subset to itself. Now, you are given two sets, he is telling us, such that a set is not the subset of the other. That means in the two sets, the sets are not subset to one another. If you have to prove this, how do you prove? Okay, if you want to prove that particular statement, then how you will prove? That's the question. Okay, we have to justify that answer also. Okay. For that, let us suppose the two given sets as A, B. So let A, B are the two sets. Now we have to check all the elements of A are there in B or not. Okay, now if at least one element of A does not belongs to the set B, then A is not the subset of B. The same we have to write Sima. We check if all the elements of A belongs to the set B or not. Okay, now if any element does not belongs to B, then we say A does not subset to B. So we have to prove at least one element of A does not belongs to B. By that we will prove the set A is does not subset to B. Sima, we will discuss another question, that is do this from page number 37. Sima, here he gave us A and B and he is asking us to find A intersection B. So A intersection B means we have to write all the common elements of both A and B. So see, in this A and B, we have the common element 7. So A intersection B is equal to 7. Coming to the second question, he gave us A and empty set and is asking us to find A union phi and A intersection phi. A union pi means we have to write all the elements of A and pi together in a new set. So see, in A I have 6, 9, 11. In empty set no element is there. So 6, 9, 11 only going to be the elements of A union pi. That is nothing but A. A intersection pi means we have to write all the common elements of A and pi. As we know, pi is not having any element. There is no common element for A and pi. So that is empty only. So empty set. Coming to the third question. He gave us A and B and he is asking us to find A intersection B, and by that we have to show that A intersection B is equal to B. First let us find A intersection B. A is the set of first 10 natural numbers. B is 2, 3, 5, 7. We know that A intersection B means we have to write all the common elements of both A and B. So A and B are having the common elements as 2, 3, 5, 7. So that is nothing but our B. So A intersection B is equal to B. Coming to that fourth one, he gave set A and B and he is asking us to find A union B is equal to B union A. So find A union B. Write all the elements of A and B together in the new set. Similarly, B union A. Write all the elements of B and A in a new set. Okay now. By observing this 1 and 2, both 1 and 2 are having the same elements. That's why A union B is equal to B union A. Try this question from the same page number 37. In that first question is, list out some sets A and B and choose their elements such that A and B are disjoint. That means he is asking us to write the examples of the sets A and B which are disjoint. Okay, now firstly we have to recall the definition disjoint sets. Disjoint sets are the two sets which are not having even a single element in common. That means we have to give examples for the two sets which are not having common elements. For that, Seema, I am considering A as set of 2, 4, 6, 8, B as 1, 3, 5, 7, 9. Is there any common element for both A and B? No, ma. That's why A comma B are the examples of a pair of disjoint sets. Similarly, A is set of ABC, B is set of W, X, Y, Z. Here also this A and B are not having common elements. So A and B are disjoint sets. Coming to the question number 2. He gave A as set of 2, 3, 5 and is asking us to find A union pi and pi union A. By that we have to compare those two results. For that, see, A union pi, we have to write all the elements together. That is 2, 3, 5. That is nothing but A. We have to write all the elements of pi and A together in the new set. Here also we are going to get 2, 3, 5. So, see, this A union pi and pi union A are the same sets. So, A union pi is equal to pi union A is equal to, that is nothing but A. Okay. Coming to that third one. See, set of A 1, 2, 3, 4, B 1, 2, 3, 4, 5, 6, 7, 8. Then he is asking us to find A union B and also A intersection B, and later we have to write the comparison of the results. Okay, now see, A union pi means we have to write all the elements of A and B together. So then I will get 1, 2, 3, 5, 6, 7, 8. Actually that is our B. Okay, now A intersection B. Set of 1, 2, 3, 4 intersection 1, 2, 3, 4, 5, 6, 7, 8. Only we have to write the common elements, then we will get 1, 2, 3, 4. That is nothing but our A. That means from this 1 and 2, A union B is not equal to A intersection B. Actually, if you want to write this as B and this as A. This is B, this is A. These are not same. See, A is set of 1, 2, 3, 4, 5, 6. B is set of 2, 4, 6, 8, 10. He is asking us to find A intersection B. A intersection B means we have to write only the common elements of the sets A and B. Here the common elements are 2, 4, 6. So A intersection B is 2, 4, 6. Now Seema, a think and discuss question from the page number 37. Here the question is, the intersection of any two disjoint sets is a null set. Justify your answer is asking. For that, we have to consider the two disjoint sets A and B. So let A and B be any two disjoint sets. As we know, the sets A and B are disjoint. There is no common element for both A and B. That we have to write clearly. A and B have no common elements in it. That is why A intersection B is empty. Why? Because we have to write all the common elements of A and B in a set. Then that set is known as A intersection B. So that's why A intersection B will become empty, as those are not having any common element. That is our justification. If you want to explain the same with an example, consider the sets A and B. A is the set of E, F, G and B is the set of L, M, N. So A intersection B is empty because there is no common element for the two sets A and B. Okay? You do this question from page number 38. Here the first question is, if A is set of 1, 2, 3, 4, 5, B is set of 4, 5, 6, 7, then find A minus B and B minus A. Are they equal? That's the question. For that, A minus B. A minus B means we have to write only the elements which are left in A. That means we have to remove the common elements of both A and B. So that's why here see ma, I am removing that common elements of both A and B. Then what are the elements left in only A ma? 1, 2, 3. So that 1, 2, 3 comes into A minus B. We are not going to bother about the elements which were left in the second set. Only we have to write the elements which are left in A. That is why it is said to be A minus B means only the elements of A. These 1, 2, 3 are the only elements of A. Similarly, B minus A means here the left out elements in B are 6, 7. So 6, 7 is B minus A. By comparing 1 and 2, A minus B is not equal to B minus A. Are they equal? He asked. No. Okay na? Your answer is no. Now, similarly another question. V is the set of A, E, I, O, U. B is the set of A, I, K, U. Find V minus B and B minus V is asking. Similarly, V minus B means we have to write only the elements which are in V. So, Seema, I am removing the common elements. Then the elements left in V are E, O. Similarly, B minus V. Okay, we have to remove the common elements. Then left out element in B is K. From this 1 and 2, V minus B is not equal to B minus V ma. Seema, the think and discuss question from the page number 38. Here the question is, the sets A minus B, B minus A and section B are mutually disjoint sets. Use examples to observe if this is true. Okay na? See, by just drawing the Venn diagram, here this indicates A minus B and this indicates A intersection B and this indicates B minus A ma. So all these three are disjoint sets. It's very clear to us, okay na, by the diagram. Why? Because there is no common place for any of these three. So that's why A minus B, A intersection B, B minus A are mutually disjoint. That will be observed by just discussing it with an example ma. So for that I am taking that set A as 1, 2, 3, 4, 5, set B as 4, 5, 7, 8 ma. So A minus B, we know A minus B means only the elements in A. So I am removing that A and B common elements 4, 5 ma. Then A minus B is 1, 2, 3. Similarly, I have to remove the common elements of both A and B and then we have to write only the elements which are left in B. That is 7, 8. A intersection B means we know only the common elements are taken. So the common elements here are 4, 5. Okay, by observing this A minus B, B minus A and A intersection B, okay na, there is no common element for any of these three sets. That indicates that A minus B, B minus A and A intersection B are mutually disjoint sets. I hope you understand this.